Hi guys, my name is Cindy and today I'll be doing hypothesis testing exercise 7.3 in our module. Okay. An accounting firm wished to set a guideline for the time required to complete a certain audit operation. A sample of times from 18 different junior auditors has a mean 3.2 hours and standard deviation 1.6 hours. Experience with similar sets of measurements suggests that the population distribution is normal. Test H0, where mu is equal to 2.6 hours, versus H1, where mu is greater than 2.6 hours, using alpha that is equal to 0.025. Okay. So basically, we will start with our first step, which is the hypotheses. And here they were very nice. They actually gave it to us, which they never do in the exam, but okay. Okay, because they said it's greater than 2.6, we then know it's one-sided. Okay, then our second step will be our test statistics. Okay, so because we're dealing with a sample here, not a population, we're going to use T distribution. Okay. Then our third step is the rejection region. So here we're going to say that we're going to reject H0 if T observed is greater than T. Okay, they gave us our sample to be 18. So here it's N-1 and alpha. So then that will be T 18 minus 1 is 17 and alpha 0.025. Could you guys?
Cindy, can I take you back to step 2, please? How did you know to use a Z or a T? Like what in the question?
Sample. Did I not mention it?
No, you did, but can you explain for someone who doesn't, like, who wouldn't be able to catch it, how it is worded?
Oh, okay.
What
So
made
elaborate
it?
more.
Yes, please.
Okay.
Yeah.
Should I erase this?
No, don't erase
Okay.
it.
So should I just automatically go back?
Yeah. Just like what in the question made it obvious for you that you're dealing with a T versus a Z?
Okay. So coming back to step 2, how to see whether you have to use T or Z. Here it says a sample of times from 18 different junior audits has a mean 3.2 hours and standard deviation 1.6 hours. So because we're dealing with the sample size, we don't have sigma. Oh, sure. That sigma needs Jesus. We rather given S. So we're going to use the equation with our S, basically. Right. Okay, so rejection region. Guys, could you please check?
T of 17, 0.025.
0.025.
Yeah.
It's 2.110.
2.110.
Yes.
Okay, then what I normally do is that I draw a picture so that I don't get confused because, pressure guys, the brain. So this is your 2.110. Basically, this value over here, this T value, is your bouncer. So we're saying here we're going to reject H0 if T observed is greater than basically this value. So if you're bigger than your bouncer, then you're not allowed into the venue. not invited to the party, basically. Right, okay. So then we come to our observation or calculation. To observe. Okay, here we just plug in the values. 3.2 minus 2.6. 1.6, 18. Could someone please check if you get 1.5910?
That's the value.
Yeah.
3.2 minus 2.6 divided by 1.6 divided by.
Yeah, 1.59.
Okay, so you get 1.5910. So this value is round about somewhere over here. So it's not greater than our bouncer, therefore we fail to reject H naught, as we had mentioned here. Okay. So you don't stop there. Now we have to calculate our p-value, Prince KB value, whichever one you want.
Okay.
And our p-value is basically t is greater than t observed. So step 5 and step 3 are actually contradicting each other, because here you said t observed is greater than t, and here you're now saying t is greater than t observed. We plug in our value, 1.591. Okay, here comes the problem now. We don't have the exact number in our table. So what we do is that we look for values where this number is in between. Okay, could you guys please look? Did we find them?
It's between the probability of t greater than 1.33 and.
But do we first say the numbers or the probability?
The numbers.
The numbers first.
Yeah.
Yeah, so we're gonna put the bigger number on there. So the
Bigger number, which one's the bigger number?
which one? It's 1.740.
1.740.
40.
And then the other one is 1.333.
333.
Yeah.
Yeah.
Okay. So our p value. No English.
For statistics.
Okay, so what's the probability?
0.05
And
0.1.
okay. So now we know that our alpha was 0.025. This is our p-value. It's in between 0.05 and 0.1. Okay, so now we can see that with this value, our p-value is actually greater than alpha. Then you go to the last step where you conclude. Now you're going to say, since T observed is equal to 1.59, it's not greater than T 0.025 and Ooh. What's something important here, like a note you can actually make for yourself. Because the p-value is greater than alpha, then we fail to reject. Obviously with this step, you can see that it corresponds with 4. So you should get 100% somewhere down the line. And our p-value is not less than alpha. We fail to reject HO at a 0.025 level of significance, as there is sufficient evidence, and conclude. Now we go back to what actually our H note meant. So basically we conclude that 2.6 hours is sufficient for the audit operations. So we don't need basically more than 2.6 hours for the audit operation.
Just a question. So you said that we are failing to reject, meaning that we are failing to reject H naught, meaning that we have insufficient evidence, not sufficient evidence. Because when you reject,
Sorry, insufficient evidence. Yeah. Okay.
Yeah.
Yeah. That's it.